Hello students, welcome to this session in which I am discussing experiment number 5, and this experiment is related with chi-square test of population variance. It is a small sample test and we will solve these two examples. What is the first example? The first example in which, see, this is the first example. A random sample of 10 students was drawn from a class. The marks obtained by these students were given. So these are the marks given. So these are the marks of 10 students. A population variance of marks is assumed to be 100. The population variance is also known. Test whether the data supports the hypothesis. So how to solve this example? So to solve this example, what we are interested is the same procedure that previously we have used. So what is the aim? To test whether the population variance of marks is assumed to be 100. Means we are testing variance. H naught is sigma square equal to sigma naught square equal to 100 for the given data. What is the test? See, we have to use this test. So chi-square is summation x minus x bar square divided by sigma square, which follows chi-square n minus 1 alpha. Alpha is the level of significance and n be the degrees of freedom. So this formula is again we can write in this fashion, n s square divided by sigma square. So this is also we can write this as equal to n minus 1 s square. So this s square is nothing but sample mean square, and this s square is the sample variance, and sigma square is the population variance. See, this n stands for the number of observations, means this is the degrees of freedom. So this S square stands for sample mean square. This S square is the sample variance, and this sigma square is the population variance. And this follows chi-square n minus 1 alpha. So this is the formula of S square, and this is S square. Only difference is for this S square we have to divide by n, and for this S square sample mean square we have to divide by n minus 1. Right? What is the procedure? See, in the procedure, so take the marks and square it and take the total. So what is summation x is 419, and what is summation x square is 19359. Means each observation should be squared. See, this is the first observation is 63. So write in this. So write the value 63 square. The next is 42. Write the value 42 square and then add all these values. So that will gives me this value. Then calculate the mean value. So what is mean? X bar is summation x upon n. 419 divided by 10. So that is 41.9. Then we have to use the null hypothesis and the alternative hypothesis. So what is null hypothesis? Sigma square is equal to sigma naught square, which is equal to 100. And what is the alternative hypothesis? Sigma square equal to sigma naught square, which is greater than 100. So means it is a right-tailed test. The level of significance in this case is 0.05. So under H naught, sigma square equal to sigma naught square, what is the test statistic? See, this is the test statistic, and we have to use this formula, summation x minus x bar square divided by sigma naught square. So either we can use this formula and find out the column of x minus x bar square. Otherwise, you can also use this formula, summation x square minus n x bar square divided by sigma naught square. So what is summation x square? See this value. So this value is 19359. So I have written this value and mentioned in this. What is n? N is 10. What is x bar? X bar is 41.9. Square it and divide it by sigma naught square. And sigma naught square is known to us. So sigma naught square is 100. So that should be divided by 100. What we are getting? So if you solve this, we are getting this value as 18.029. Now we have to table the value which is needed is a table value. So table chi-square can be obtained such that for right-tailed alternative, the critical region is, this is the critical region. So probability of chi-square greater than equal to chi-square n minus 1 alpha equal to alpha. What is the value of table chi-square? So table chi-square is this value. So this is the value of table chi-square n minus 1. So what is n? N is nothing but the number of observations. How many observations were there? 10. 10 minus 1 is 9. The level of significance is 0.05. So the value which we are getting is 16.919. I will show you how we can get this value from the table, right? So how to get this value? Just I will show you the table, chi-square table. I have provided to you this table also. Now go to this table and check the values 9 and 0.05. See, this is a chi-square distribution table. The level of significance in this case that we are interested is 9. So check the value 9. So this is the degrees of freedom in which we have to take the value as 9. And what is this is 9 is the degrees of freedom. So this value 9 is the degrees of freedom, and the level of significance that we needed is 5%, means chi-square 0.05. Then the value which is in the intersection, which one? See, this is 9 and this is chi-square value. So this is 16.919. So this is my table chi-square. See, in this first column is the degrees of freedom and the first row is the level of significance. So first value should be my degrees of freedom. The next value is my level of significance. And accordingly, the value which is in the intersection of this, see, I have seen this value 9 in the first column, and in the row, I have taken this value 0.05 as my level of significance is 5%. The value comes out to be 19.919. This is the intersect value, level of significance and degrees of freedom. So once I know that this value, then compare this value with the table value. See, calculated chi-square is how much? Is 18 point, and table chi-square is 16 point. So therefore, calculated chi-square is greater than table chi-square. Hence, we reject H naught. So reject H naught means we have to accept the alternative hypothesis. And what is alternative hypothesis? The data does not support the hypothesis. So this is the uh, our example number 1. So what is example 2? See, the example 2 is related with, say, a random sample of size 10 from a normal population gives S square. S square is given. Test uh, at 5% level of significance. Sigma naught square is 80 versus uh, which is not equal to 80. See, in the first example, the data is given, but in the second example, we have already given this S square value, and the level of significance is also known, and the value of sigma naught square is also known, and the level of significance and the degrees of that is the sample size is also known. So four terms we know. So one is n, the second one is s square, the third one is alpha, and the fourth one is sigma naught square. If all these values are known to us, then it is easy to find out uh, to test the hypothesis. So see, this is my chi-square test. These are the values known to us. So n is given, s square is also given, and sigma naught square is also given. And what is my procedure? Sigma square is equal to sigma square which is greater than sigma naught square. So that is a right-tailed test. What is the level of significance? The level of significance is alpha, right? So if you calculate this value, how much I am getting? See, this is the value. The calculated chi-square is 11.25. And now we have to check the table value. So table value for 9 is n minus 1 alpha. N minus 1 alpha is 9, and the same value we are getting 16.919. So calculated chi-square in this case, calculated chi-square is 11.25. Table chi-square is 16.919. So therefore, calculated chi-square less than table chi-square, we accept H naught. So accept H naught means what? So accept H naught. So this is accept H naught means what? See. So I will remove this. So what is my acceptance of this H naught means that the population variance is 80. Population variance in this case is how much? 80, and that we are accepting, right? In this way, you can solve